Alright, so today I kind of want to talk a little bit about an experience I had through NASA called the Community College Aerospace Scholar Program. Before I get going on that, I want to give you kind of an idea of how I stumbled across this program. And then I'll talk a little bit about what I learned there about mathematics that's used at NASA and exactly what I did while I was there. So when I was at a two-year institution, I was a member of Phi Theta Kappa. It was an honor society for students who academically did well. I kind of felt a little skeptical at first because I didn't really hear anything about it the entire time I was there for my first semester. It was one of those things where you did good, got a grade, and they sent you an invitation that I felt really was like a mass invite. So I did some research, and one of their foundations was scholarship, and it enticed me to join because I was guaranteed a $1,000 scholarship once I transferred to a four-year institution. The next one was leadership, which is obviously another good plus because I think that's a skill that everyone should possess. Fellowship, it's a picture of our induction. It's really a small bit of what the fellowship entails, because fellowship through Phi Theta Kappa could be anywhere from chapter to international. And then service, and that's where I was sold because I always really tried to look for ways to give back to the community. So through my experience at Phi Theta Kappa, I quickly became the president and had a lot of really awesome things happen for me through that. In the middle picture, I was awarded the Minnesota All-State Academic Award. Didn't win a scholarship, but I came pretty close. So I tried to make our chapter kind of become more of a mainstream thing on our campus, and I realized that I was running out of time. So while I was doing research on how to hand over ideas to the up-and-coming president, who was also equally excited about all the things that have happened for me, I stumbled across this NASA program, and I was like, well, what the heck? There's 2 days to apply, why not? I knew absolutely nothing about it. I knew the only thing that mattered is that I was intending to go on to a four-year institution for a STEM field, which is science, technology, engineering, and mathematics. And I thought it's worth a shot. The worst thing that would happen is I wouldn't hear back from them and it would be no big deal. Well, I heard back. I was one of 1,200 students throughout the country to hear back. And here's when it got hard. They wanted me to do homework. I thought this was going to be one of those things you sign up for and have fun. No. So 3 months time goes by and I had 5 assignments to hand in. The last one proved to be kind of daunting. I had to build on paper like a schematic for what I would want to have for a vehicle on Mars, because we planned an entire mission from beginning to end. And once this went through and they graded it, I was one of 80 students accepted to go on to the program. I learned a lot about what it meant to build, a mission from beginning to end, but not enough to where I felt qualified, I guess is the right word. So I was really eager at this point to learn more because I knew I would. NASA has 12 centers that are active within their name throughout the country. There's a lot more research going on at other independent private places. I wasn't really sure exactly where I would end up, but I knew it would be stuck between either the Jet Propulsion Laboratory or the Johnson Space Center in Houston. I think luck as it has it, I ended up at the Jet Propulsion Laboratory in Pasadena, California, which technically is part of Caltech's property. In fact, everyone that works there gets paid through Caltech, but through their contract, they get to keep the name of being a NASA facility. As you see, I think it's very unique in beauty, kind of compared to where we are with the mountains. It's pretty vast campus. I was pretty overwhelmed when we got there because I didn't expect it to be as big as it was. So as we rolled in, there was 40 of us students. We got kind of tucked into 4 teams of 10, and we would take turns taking, I would say, I don't know, tours, if you want to call them that. That's a very loose term. We were given access to some places that would say or restricted access, and we didn't have to do any like security clearance or background checks. So I didn't understand like how all that worked. So I didn't know that I should call them tours, but this is when I kind of start learning how mathematics is applied in like the NASA sense. And I should go back and say that I kind of knew at this point that the realm of the mathematics I wanted to go into was more of like data analysis, more statistical. Before I got to this experience, I really wanted to go into biostatistics, but I didn't know that that meant going on to grad school, more so than it does your bachelor's degree. The biggest thing at the Jet Propulsion Laboratory that I found fascinating was the fact that they're the mission control for all unmanned spacecraft, which means satellites, rovers, space vehicles, etc. That is kind of actually a lot bigger in a scheme of things than what I really understand. But mathematics plays a huge part in this. How we get to Mars is all mathematical. I got to meet the chief engineer for the flight path for Curiosity to go from Earth to Mars. As you see, it should just be a straight shot from where, you know, Curiosity was launched at Earth into Mars. But what I learned is that the amount of fuel and energy that that would take to go in that straight shot wouldn't get the rocket off the ground in Florida. So through all of their physics and aerospace knowledge, they found an easier path, which is the green one. Now I'm a little intrigued. I don't feel very smart when it comes to a lot of mathematics, and I definitely feel kind of overwhelmed being the only person in this program that has anything to do with mathematics. But the guy talking my ear off about this actually made my entire trip worth it. The other thing I found fascinating was how much data is really collected through the mission controls, especially since I want to go into data analysis. Not only are they mission control for all unmanned spacecraft, but they are kind of like the second headquarter for a lot of the information going back and forth between satellites and Curiosity, which is a rover on Mars that I'll get to in a minute. And there's a whole team of people, not necessarily in this building, and this is just like the main computer, that is working on cleaning up that data, understanding what's going on with that data, answering questions, and so forth. Next, they are the home of the Mars Science Laboratory, which is where the rovers that have been on Mars and currently are kind of were created, born, and tested on. When we were there, it was 2012, May of. Curiosity didn't land on Mars until August of 2012. They were actively running troubleshooting problems to know, like, well, if this goes wrong, how do we fix it? In fact, there was a few scientists that included one applied mathematician who had a doctorate in applied mathematics on the ground while we were there that day. They were trying to figure out, like, if let's say that one of the cameras stops taking picture in color, if we try to fix that from the ground, will fixing that affect how something else on Curiosity works? I just found it really interesting that while Curiosity is in flight to Mars, that they are able to go through and have all these plans in place for what might happen. So that's just a picture of Curiosity that landed in 2012. Spirit and Opportunity were identical rovers that landed in 2004. Opportunity is still contacting Earth. Spirit is kind of since fell off Mars per se, but it's still there. It's just not contacting us anymore. Some other things that were pretty cool. The Flight Project Center is kind of where the chief engineer of Curiosity's flight path is located out of. A lot of applied mathematicians are in that building, where they're working on all kinds of things, whether it's how do we put another satellite in orbit for a certain particular reason without it crashing into ones that are already there. There's the mechanical design center. A lot of engineers work out of there working on new projects or ones that are up and coming. Such as athlete, I just threw that picture on there to kind of give you an idea of the things that they're working on that might have mathematics applied but more in the background.
Got 1 minute left, okay?
Okay. So I'll just kind of briefly go over, this was my team. We worked on another mission to Mars as we were there as a team. And we built a robot rover that was supposed to simulate one that would go on Mars. It actually went on an obstacle course. Halfway through our time there, we did a mock run through of our obstacle course and gave a presentation, and we were in last place. We ended up coming back and winning, which was actually a really interesting and awesome experience. So if you have any questions later, I'd love to share those with you.
So did you get paid to? part of this?
The pay to participate was that they paid for our flight, our hotel stay, and all of our food while we were there.
And how long was it?
It was a 5-day experience. And I noticed when I was kind of looking up some things to like add for pictures, I noticed that they no longer go to JPL now. They only go to the Johnson Space Center, which I think is a shame because really the JPL is like all about mathematics.
Sounds good, thank you.